Hello everyone, this is a new video in which I'll be discussing questions from which I'll be discussing Jest PYQs. Okay, and here I'll be discussing 2024 paper and especially I will be discussing classical mechanics. Okay, so all the classical mechanics questions that came in 2024 I'll be doing here. Okay, so let's write one by one and let's try to solve. So this is the first question. First question is classical system has the classical system has the following action. S is equal to integration of q dot square plus alpha q dot plus beta q square q dot, okay, and dt, where q is the generalized coordinate where q is the generalized coordinate, okay, and alpha and beta are constants, okay. which of the following statements which of the following statements which of the following statements is true about the dynamics of the system, is true about the dynamics is true about the dynamics of the system. So this is the action. Classical system has the following action. Which of the following is true? Option A, dynamics depends only on alpha. It depends only on option B, dynamics is independent of alpha and beta. Okay. Option C, dynamics depends only on beta. Dynamics depends only on beta. Okay. And option D, dynamics depends on the ratio. Dynamics depends on the ratio alpha by beta. Okay. So yeah. So the action of the classical system is given here. S is equal to q dot square plus alpha q dot plus beta q square q dot dt, where q is the generalized coordinate, q dot is dq by dt. Okay, time derivative of the generalized coordinate is q dot. Okay, which of the following statements is true about the dynamics of the system? So these are the options, right? So we have to find out dynamics of the system. That means you just have to find out q double dot. Okay, and q double dot you have to check like what terms it depends on, and that will be the dynamics of the system. All right. So you can give a break, like pause it and try to solve. Otherwise, you can see here how we solve it. So the again, I will write whatever action is given. Right, S is equal to q dot square, right, plus alpha q dot plus beta q square q dot, yeah, dt. So this is the action of the classical system. All right. So from the action of a classical system, what can we conclude? Actually, action formula S is equal to LDT. Okay, LDT, where L is actually Lagrangian. Okay, L is the Lagrangian. Lagrangian means your kinetic energy minus potential energy is the Lagrangian. All right. So this is eventually this is actually L dt. So L is equal to what? Q dot square plus alpha q dot, okay, plus beta q square q dot. So this is the Lagrangian. Okay. So from Lagrangian we have to find out the acceleration. We know simple, that, okay, we know the equation of motion, that is d by dt of del L by del L del q dot, okay, del q dot plus del L by del q is equal to 0. We know this is equation of motion. So let's calculate. We will put like calculate these terms and put it here. So del L by del q dot is equal to 2q dot plus alpha q, yeah, plus plus beta q square, correct? Okay, all right. So now this term becomes d by dt of del L q dot. So d by dt of, I'm doing step by step. You rather try to do faster. Okay, I'm just doing it for your like understanding. Q dot q double dot, because d by t of del L by del L q dot, then is this thing. So d by t of q dot is q double dot, right? And this is alpha q dot plus 2 beta q into q dot, right? Derivative of q square is 2 beta q and time derivative is q dot. So this is this term. Now del L by del L by del q is how much? From here, if we see these two terms have only q, so alpha q dot plus 2 beta q dot. All right. So these, now we will just put it in the equation of motion. All right. So if we put it in the equation of motion, so d by dt of del L by del q dot plus del L by del q, okay, is equal to 0. Sorry, this is minus. I'm really sorry. This is minus. Very simple mistake. This can happen in exam also, but be careful. Okay, this is the equation of motion. I'm really sorry. Okay, yeah, is equal to 0. So let's put the values. So first of all is this one. So 2 q double dot plus alpha q dot plus 2 beta q dot minus alpha q dot plus 2 beta q dot, okay, is equal to 0, correct? So let's open it. If we open it, 2q double dot plus alpha q dot plus 2 beta q dot minus alpha q dot minus 2 beta q dot is equal to 0, okay. So these two terms are getting cancelled. So q double dot is equal to 0. So this is the acceleration, right? So q double dot is equal to 0. That means it is a dynamic of the system is independent of alpha and beta, right? So there is no dependence on alpha and beta in the acceleration term or q double dot term of the system. That's why there is no alpha and beta here. So there will be no dependence on alpha and beta. Okay, that is the answer. Question number two. Two classical particles. Two classical particles moving in three dimensions, interact via the potential, interact via the potential, interact via the potential V is equal to k x1 square plus y1 square plus x2 square plus y2 square plus z1 minus z2 square. Okay, where k is a constant, x1, x2, x3, you know the Cartesian coordinates. Okay, let p1x, p1y, p1z and P2x, P2y, and P2z be the components of be the components of the linear momenta of the two particles, all right, and L1x, L1y, sorry, L1z, and L2x, L2y, and L2z. Okay, the components of corresponding with the components of corresponding angular momentum, corresponding angular momentum. All right. So which of the following statements is true? Which of the following statements is true? Okay. So the options are option A, L1z, L2z, and P1z plus P2z are conserved. Option B, L1z, L2z are not separately conserved. Are not separately conserved. But L1z plus L2z is conserved. Is conserved. Right. Now option C, L1x plus L2x, L1y plus L2y, L1z plus L2z are conserved. And option D, L1x plus L2x and L1y plus L2y are conserved. So this is a very long question. So I hope you try to solve it. You please take 1-2 minutes and solve it. Right. So how to solve this question? Whenever there is a question about which terms are conserved, so the process is what? What is the process? We have to take the uh, commutator of that quantity with the Hamiltonian, and if it is zero, then we'll say it is conserved. If it is not zero, it is not conserved. Alright. So we'll check one by one. Suppose L1x. Okay. So L1x is, we can write it as x1. Okay. And it's a very E1y minus y1 E1x. It's a very weird notations these are. So we have to be a bit careful. Okay. So we know Hamiltonian is how much? Do you know the Hamiltonian for this system? Hamiltonian for this system will be P1 x square plus P1 y square, not P2. P1 y square by 2m plus P2 x square and P2 y square. I'm writing it along with here because otherwise it will get confusing. Okay? So I'm doing it as per my convenience. Okay, divided by 2m, right, plus k whole into x1 square plus y1 square plus x2 square plus y2 square plus z1 square plus z2 square, okay, minus 2 z1 z2. All right. Okay. Now, so if I take the Hamilton, like, sorry, the commutation of L1x with H. Okay, let's check L1x with H. If we take the commutation, you have to do one by one. Okay, so it will be like x1. Okay, p y1 y1 z, because yeah, p y1 z. There is this because I'm taking here only. Okay, plus sorry into k plus p y1 x1 plus p x1 square by 2m. Okay, so this is a comma here. Okay, minus y1. Try to do it yourself. Okay, x1 square k minus px1 or 1x whatever y1 py1 square by 12. Okay, so if you actually try to solve it, so this is L1z. Okay, sorry, L1z. If you actually try to solve it, you will get 0. All right, because I have taken it L1z. Sorry, my bad. It's L1z. Okay, my bad. So L1, this will actually become 0 if you expand all of this. So L1z commutation with H is actually 0. Okay. Similarly, we can prove that L2z with Z, H is equal to 0. Okay, right. So now you can also prove, if you do it slowly, you can also put P1z plus P2z along with H. Okay, you can prove this one also. Okay, so if you see K whole into P1z Z1 square, only with the terms that it will commute, other like it will have some term, otherwise you can cancel others. Okay, minus 2k2z. I'm just not writing all the terms because every other term will give rise to 0, right? So I'm not writing them. Z1 is k whole into p2z z2 square minus 2k z1 p2z z2. Okay, right. So see, this one will give me minus 2k z1, right? Yeah. And IH cut will be there. So forget IH cut. So this one will give me 2kz2 minus IH cut it will be giving me, but there is this minus minus plus, but IH cut I will ignore. Alright. This one will again give me minus 2k z2 IH cut. Okay, I'm just ignoring this 2k z1 because minus minus become plus. So if you this see, this is all cancel out. Okay, and they're all cancelling each other, so that will give me 0. So which terms L1z, L2z and P1z plus P2z are the conserved quantities. All right. So option, which option will be correct? Yeah, this one, option A will be correct. All right. Yeah. Question number 3. Question number 3. Okay. A cylindrical rigid block. Cylindrical rigid block. Okay. Has principal moments as principal moments of inertia. Mi, I'm writing as mi. Okay. Principal moments of inertia I about the symmetry axis. About the symmetry axis. Okay. And 2I about each each of the perpendicular axis. Each of the perpendicular axis passing through the center of mass. Passing through the center of mass CUM. Okay. At some instant. At some instant, the components of angular momenta, the components of angular momenta, angular momentum about the center of mass in the body, in the body fixed, in the body fixed principal axis frame is LLL with L greater than 0. What is the cosine of the angle? Cosine of the angle between angular momentum and angular velocity. Angular momentum and angular velocity. Okay. The options are 2 by 3, option B 2 by root 6, option C 2 root 2 by 3, and option D 5 by 3 root 3. Right. Let's try this question. So how to solve it? This is a cylindrical rigid block as principal inertia of moment of inertia. Okay, see, So how to solve it? So we know angular momentum L is equal to I omega, right? I omega. So see, L as given in the question can be L, right? We'll do it in the matrix form. Your angular moment of the each perpendicular axis is 2i, 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 right? So 2i is 0, 0. I hope you have solved this kind of question before, so I'm just directly doing it. And omega, we know, has three components: omega x, omega y, and omega z. Correct? So, very simple, you can match on both sides. So, your omega x will be L by 2i, omega y L by 2i, and omega z. Sorry, this is I here because, my bad, this is I here. Why I? Because, see, it has a principal MI about the symmetry axis. Okay, symmetry axis, okay, and 2i about each of the perpendicular axis. So two axes we have to take 2i, and one axis we have to take I. So I just chose it to be z axis. So the omega z is equal to L by I. All right. Okay. So if I write omega, omega can be written as L by 2i x cap plus L by 2i y cap plus L by I z cap, right? Yeah, and L can be written as we know I sorry L x cap plus L y cap plus L z cap. All right. Yeah. So cos theta, we need the angle between angular momentum and angular velocity. Angular momentum and angular velocity. Any two vectors, if I need the angle between them, what will I do? Cos theta is equal to A dot B divided by AB. So cos theta is equal to L dot omega divided by L and omega. Correct? Yeah. So L dot omega will be, you can see here, L square by 2i plus L square by 2i plus L square by I. Alright. Whole divided by, if we say the magnitude, this magnitude is L, right? It has magnitude L. Yeah. Or what? Sorry. L square plus L, L square plus L square plus L square root over. Right? So this is root 3L. And it has magnitude um, L square by 4i square plus L square by 4i square plus L square by I square root over, right? So 1 plus 1 plus 4, 1 plus 4, 6 L square by 4i square root over 6 L square by 4i square root over. So that is, this is 3, this is 2. So root over of 3 by 2 L by I, correct? So root 3 so okay, 3 by root 2 L square by I, correct? Okay, so the numerator becomes 4L square by 2I whole divided by, this becomes root, this is already 3 by root 2 L square by I. These are calculations I'm speeding up because we have to do it faster, right, in exam. So this becomes 4 by 3 root 2. So cos theta is equal to 4 by 3 root 2. Or did I do any mistake? Yeah, alright. Yes, no. So this is root 2, this is 2 root 2, right? So 2 root 2 by 3. So cos theta is equal to 2 root 2 by 3. Yeah, so that will be the answer. Answer is in terms of cosine of the angle. So 2 root 2 by 3. Yes, option C will be the correct answer. Okay. Okay. Next question. Question number 4. Question number 4. Let P and Q be the canonical phase space coordinates with the canonical phase space coordinates. Sorry, coordinates of a system where Q is the generalized coordinate. Q is the generalized coordinate CN, okay, coordinate, and P is the generalized momentum. Okay, P is the generalized momentum. So let's make a transformation. Let's make a transformation. Let's make a transformation of the generalized coordinate as Q is equal to Q square. Okay. So which of the following is canonically conjugate to which of the following functions? Which of the following functions is canonically conjugate to Q, right? Yeah. Q. Okay. So option A, P square by 2Q square. Option B, P by Q. Option C, P square. And option D, P by 2Q. Okay. Let's try. This is one the easiest question among all. Please try. Okay. So how to solve this one? Easy question. Let's see. Again, what is the question? Let's read it out. Q P. Okay, relation is Q is equal to P. Q is equal to P square. So which is canonically conjugate to Q? How? How will we do it? Canonically conjugate to Q. That means we have to see whether they are this one canonically conjugate to. Suppose X is canonically conjugate to 2. Suppose that means we have to find out. We have to check whether their Poisson bracket. Sorry, their this commutation is one or not. Okay. See, let's check. So of P square by 2Q square with Q. Okay. So how will we check it? So 1 by 2 Q square goes out. So P square with Q. Q is your Q square. Okay. So if you check this one, 1 by 2 Q square, this is 2P, P by Q square. Derivative of the this one and goes out, right? So this is P by Q square. And derivative of this one also goes out. 2Q and this is PQ. So PQ is what? Minus IH cut, right? Or 1, suppose. I take minus 1. So it doesn't fit into it, right? So this is not giving me 1, right? So this is not the answer. So option A is not the answer. Now P by Q. Okay, P by Q I will check with Q. Q is what? Q square. So P by Q, Q square. 1 by Q goes out. So PQ square. So 1 by Q, this is 2Q. And this is PQ, right? Yeah. So if you see, this is 2Q by P. And this is minus IH cut, right? So again, this is not also giving me, this is not giving me 1. So option B is also not correct. Okay, now P square Q square already checked here that it's not giving me anything, right? Now we'll check P by 2Q. Okay, P by 2Q with Q. That is P by 2Q with Q square. Okay. So 1 by 2 q, and this is pq square. Okay, see now here, if you check, if you check this one, and this is going out 2q by 2q, right? This is pq, right? So this is cancelling out, so only pq is there, right? So if pq is there, that will give me 1. Okay. Also this can be done through Poisson bracket if you can do it. Okay, see, del p by del q, del q by del p minus um, del p by del p into del q by del q, right? This is minus 1. So minus 1, 1, almost similar. All right. Like almost we have to kind of do it this way only. Okay. We don't have any other option. So this way also you get minus IH cut. Okay. If we take the magnitude, that will be 1 only. So yeah. So option D will be correct. Like we have to see whether it doesn't have any coefficient with it. Okay. That one we have to check. So option D will be the correct answer. Next question. Question number 5. Question number 5. Particular mass m, particular mass m, and non-zero angular momentum L. Okay, I'm just writing in shortcut. Subjected to subjected to a central subjected to a central force potential. Subjected to a central force potential. Okay, VR is equal to K ln R. VR is equal to K ln R, where K is the positive constant. What is the radius R? Okay, the question is what is the radius? What is the radius R, and and which and okay, at which it can be, at which it can have a circular orbit. It can have a circular orbit. All right. Will the circular orbit be stable or unstable? Will the circular orbit be stable or unstable? Yeah. So yeah, try option A. R is equal to L by root K m, and this is stable. Option B. R is equal to L by root over of K m. This is unstable. Option C. R is equal to L by root Kn, and this is unstable. This is stable. Option D. R is equal to L by root Km. This is unstable. Okay. So yeah, try. Potential is given. You can easily calculate which one is stable and unstable. Okay, let me just do it then. Potential V effective we know is L square by 2mr plus VR, right? What is VR here? K ln R. So L square by 2mr plus K ln R, right? So del V effective by del R will be how much? Minus L square by mr square, 2mr square plus K by R. This is del V effective by del R. Okay, we have to equate it to 0. So minus L square by 2 m r square is equal to minus k by r. So minus minus cancelled out. Here r are cancelled out. Okay. So r, okay. From here we get r is equal to L square by 2mk. Correct? So this is the r. Now I'll put it in the expression of del square v by del r square. Del square v effective by del r square, which is I have to take another derivative of it. So it will be how much? How much it will be? L square by minus L square by, okay, del by del r of minus L square by 2 mr square. Did I do a mistake? Okay, sorry, this is sorry. This is really bad. This one is really bad. I'm really sorry. Okay, let me do it again. I made a mistake here. Very silly mistake again. L square by 2 mr square plus k ln r. Okay, let me do it again. Okay, so V effective is equal to L square by 2 mr square plus k ln r. So del V effective by del r is how much? Uh, Minus L square by m r cube plus k by r is equal to 0. Correct. So minus L square by m r cube is equal to minus k by r. So minus minus cancelled out. This is r square. So r square is equal to L square by mk. Correct. So r is equal to L by root mk. Alright. So now what will I do? Del square V effective by del r square is equal to, this is 3 L square by m r fourth minus k by r square. I will do what? I will put this value of r here. Okay. So 3 L square by m, L square by m, m square k square. Okay. M, this L cell cancel out. So k square by m. Okay, sorry. Minus k by r square is also there. Minus k by r square is L square mk. Okay. So again, this is, again I'm doing some mistake. Uh, okay, this will go up, right? Okay, so this becomes, okay, I'm doing some mistake here. Okay, this somehow will become 2mk. I'm just writing the final answer now. By which will be greater than 0. If it is greater than 0, okay, yeah, this is mk square by L square. This is L square is getting cancelled, or this is the problem here. Oh, okay. L fourth, R fourth now. So this will become L fourth. Okay, again, let me. 3 L square by M, L fourth by M square K square. Correct. So this eventually gives me 3mk square by L square. Yeah, this is 3mk square by L square minus mk square by L square. So 2mk square by L. Okay, L square, which is greater than 0, which is a stable orbit. Okay, this is a stable circular orbit. Yeah, all right. So, so these are some of the questions from classical mechanics we did today. So yeah, I hope you understood. And yep. So yeah, I'll be solving more questions in the like upcoming sessions. Okay. Okay. Thank you very much. Yeah.